In this, the second of our videos on refraction, we're going to take a deeper look at the subject by looking at something called Snell's law. In the last video, we looked at the basics of refraction and how when light moves from one medium to another, it changes direction. In this video, by using and explaining Snell's law, we will be able to not only understand that light changes direction, but we will be able to predict by how many degrees it will change. In other words, if we know the angle of incidence, we should be able to calculate the angle of refraction. So how do we define the terms angle of incidence and angle of refraction? Well, in this topic it's important to remember that any angle that we measure is always measured between the ray of light and the normal line. So the angle of incidence, we just get the incident ray here, and it's the angle between that ray and this normal line here. We can call that I for incidence. The angle of refraction, well, we take the refracted ray here, and similarly we draw the angle between it and the normal. This one is usually labelled small r. Down here, this could also be counted as another angle of incidence, and here this could also be counted as another angle of refraction. But for now, let's just concern ourselves with these ones here. If we know the angle of incidence here, is it possible to predict what the angle of refraction will be here? And likewise, if we know the angle of refraction here, is it possible to predict what the angle of incidence is here? And the relationship between this angle of incidence and between this angle of refraction is what's known as Snell's law. But before we understand Snell's law, we have to think of something called refractive index. Every medium that light travels through has a refractive index. A refractive index is just a number. It doesn't have units, and it's often written as the symbol n. Now the equation for refractive index for any medium is as follows. It equals the speed of light in a vacuum. Now the speed of light in a vacuum is the fastest thing there is. So it's the speed of light in a vacuum, and we get this number and we divide it by the speed of light in the medium. So it's the speed of light in a vacuum divided by the speed of light in that particular medium. So the medium could be water, the medium could be glass, for example. Let's use glass as an example. If we wanted to find the refractive index of glass, we would put the speed of light in a vacuum, which is 300,000 kilometers per second, very roughly, and we would divide that by the speed of light in glass. Now I know in glass it goes slower. It's actually about 200,000 kilometers per second. That would mean that the refractive index of glass would be equal to 1.5. Now there are no units there because the kilometers per second here have cancelled with the kilometers per second over there. Refractive index is very useful because it can tell us about the relationship between these two angles. In this situation, we've got light going from air into glass again. You can see that it's been refracted towards the normal line, and we've got the angle of incidence here, and we've got the angle of refraction. Well, according to Snell's law, we can say that the sine of the angle of incidence divided by the sine of the angle of refraction is equal to the refractive index of the substance. So in other words, if we get the angle of incidence and we put it in our calculator and press the sine button, do the same with the angle of refraction there, divide one by the other, it will give us the refractive index. So if this was glass, the sine of this divided by the sine of this would always give us 1.5. So that's the basics of Snell's law. In the next video we will use the law to answer some questions.